So I'll extract it right here. Okay, and then you'll get the files in something called the folder called Webots sample code master. And you want to go to day one, mini challenge one, worlds, and then level1.wbt is the worlds file. You want to open that using Webots. So right now I'm going to pull up Webots. I already have it open. This is just the level one world. You can open it by going to File, Open World, and then finding level one world wherever you extracted the folder. So just to give a big picture of the Webots environment, at the top, you'll find the simulation control buttons, and that includes playing and pausing, as well as resetting the simulation. This is the reset button. This is play and pause. And in the middle of the screen, this is the actual simulation within Webots. So you can use this to see what's going on in the simulation, as well as you can click within it to interact with the objects. To the left, you'll see the scene tree. And the scene tree just lists every single object within this environment. At the bottom, you'll find the console. This is where error messages are printed, as well as print statements from your robot controllers. And to the right, this may not immediately show up when you first install Webots. You can bring it up by going to Tools and then Text Editor. So this is just the built-in Webots text editor that you can use. You can also choose to use some other form of text editor or IDE of your choice. But we're going to be using this one because everybody has it when you install Webots. All right, so Jeffrey's going to talk about the structure of a Webots C++ controller. So I'm going to stop sharing.
Okay, so as Victor said before, here we have our Webots environment. And in this middle right here, this is our world. This is where our simulations get run. And the overall idea behind Webots is we can write some code and we can link that code to certain robots right here. So I can write my file and then I can attach it to this robot right here. And any programs that we write that are supposed to be linked to robots, those are called robot controllers, right? So any .cpp or .py, any code that you write, we're going to call them robot controllers. Okay, so to create a new robot controller, you can just go over here to Wizards, then New Robot Controller, and then hit Next, and then choose whatever language you want. We're going to be doing C++, hit Next, and then we're going to be working with the Webots text editor, so that's fine. And then you can name your controller, and then I'm going to hit, and then I'm going to hit Finish. And as you'll see, it will generate a robot controller for you. And over here is where you can type your code. I'm going to be using a different text editor just so you can see it a little better. So over here, what I have is a bare bones robot controller. This is the bare bones of any Webots robot controller you want to write. And there are four main components. The first component is your pound include right here. And basically, every time you use a robot, motor, or sensor, you're going to have to include the appropriate header file for that robot, motor, or sensor. We'll talk a little bit about this later. The next part is creating a robot pointer. So all this does is if you have to create this, which creates a pointer to the robot object. And then now we have this robot pointer, and we're going to use this robot pointer to call specific robot methods, such as right here, we call getBasicTimeStep, which is a robot method. And that leads me to the third component, which is your time step. Now, the overall idea behind a Webots robot controller is that it runs your main function. So it runs all of this once because it's not looped. But then it's going to loop this main while loop over and over again continuously at a very fast pace. And what the time step is it's the interval between iterations of this while loop. So let's say my time step was set equal to 32. That means that this while loop is going to be executed every 32 milliseconds, right? So let's say I put a print statement in here. This print statement is going to be executed every 32 milliseconds. So it's going to print every 32 milliseconds, right? So all this code that's inside of this loop, everything that goes inside here gets executed every 32 milliseconds. Then all code outside of here is going to be run only once because it's not looped. So I'm going to add a print statement, only gets printed once, right? So now we have a very simple robot controller to run. So let's see how we can run this. So what I'm going to do is I'm going to make sure that it's saved. I'm going to hop back over in Webots. And then I already have this pulled up inside my Webots text editor. And this part is actually very important. So what we're going to do is we're going to go to this gear right here. I don't know if you can see my cursor. There's a gear right here. And we're going to build the current project. So we're going to hit build. And then you can see over in the console down here, it's going to start building. And then build finished. So we can just hit cancel on this. And now we successfully compiled our code. Now what we're going to do is we're going to take all this code and we're going to link it to this robot right here. So this robot knows to run this program. So we're going to navigate over to this window right here, which is called the scene tree. We're going to click on our robot, and one of these is going to light up. You can see it's the Define Robot Pioneer 3DX. We're going to hit the drop down. We're going to go to the controller field right here, and then we're going to double click, and then we're going to select, and then we're going to select the robot controller that we want to use. So you can see that I'm working with samplecontroller.cpp. So I want to click on sample controller. Then I hit OK. And then this is also very important. You have to save your world using this button right over here. So we're going to save the world. Now, this code is linked to this robot. So then all we have to do to run this code is just hit this play button right here. So we're going to hit play. Let's try it one more time. There we go. So I hit play and then I paused it pretty quickly. But then if I scroll up, you'll see that this print statement only got printed once, right? If I can move this up, this print statement only got printed once. However, the other print statement that was inside this loop, this print statement right here, got printed every 32 milliseconds, so really quickly. And just for demonstration, let's say you forget to add a semicolon or something. So you did something so that there will end up in a compiler error. So if I go to build now, you will see that it will throw me a compiler error. It will complain that there's no semicolon here. So if you have any basic syntax errors, this build function right here will catch them for you, and you can look to your console window to see why. So now, one more thing before I turn it over to Victor is, if we go back to this main page that we were talking about before, if you go to, let's see, support and assistance. So this card right here, it'll flip over for you, and you can click on this Webots Documents website. If you click on it, it will open up to this website right here, and we're going to click on documentation and then reference manual. Then we're going to click on nodes and API functions right here. This place is where all of the Webots API is documented. So any API call that you might need or you're curious about will be written in this documentation over here. So for example, let's say I wanted to learn about the accelerometer. I could go to accelerometer, and they have all the information that you need in all the different languages. So if you have any questions or you need to figure anything out, this is the place to go. So now we're going to turn it over to Victor so he can talk about motors.
Sorry. All right. Right here in the text editor, I have a sample file pulled up called motormovement.cpp. And this sample code is actually also available once again in our GitHub under day one, and its name is motormovement.cpp. So I'm going to walk you through, first of all, how to use the motors. And next, we'll talk about the position sensors. But first, we're going to cover the motors. So first thing before you start using the motors is you need the appropriate include statement. And that's just pound include webot/motor.hpp. So after you include that, you can start using all the motor related Webots API. So the first thing you're going to want to do is create your motors. And this robot features two motors, one for the left and one for the right side. And they're both called left wheel and right wheel, respectively. So the left motor, what we do is very similar to how we created a robot. We say motor, we create a pointer, left motor equals robot, get motor, and then the name of the motor is left wheel. And similarly for the right motor, we do the same thing. And we're not going to worry about the position sensor yet, but we'll talk about that later. And you'll see that we still have our time step here. And so here's what is important. There's two main functions associated with using your motors that you're going to need to know. The set position functions, as well as the set velocity functions. So the set position functions sets a desired amount of radians the motor should turn. So this unit 20 is in radians. So what I'm saying by set position 20 is I'm setting the left motor to move 20 radians. And down here for the set velocity, that is also in radians. So when I set velocity to be 10, I'm asking it to move at a speed of 10 radians per second. Now, these motors do have a max speed, and it depends on which robot you're using. For this particular robot, I believe it is 10 radians per second, but once again, it's going to depend on what robot you're using. So we're setting both motors to go at 10 radians per second, and we're setting the positions to go for 20 radians. So we save that. If we build it, and then you have to remember to attach the correct controller. And this is called motor movement. So I'm going to select that controller. All right, so if we run the robot, you'll see that it moves forward 20 radians and then stops. So this was something called position control. We used what Webots calls position control on our motors. And position control is basically self-explanatory in that you set the desired position that the motors need to run for, as well as the velocity, which is the speed they run at. But there's also another form of control you can use. You can also use velocity control. And when you use velocity control, you ignore the position. So the robot pretty much runs as long as your velocity is not 0. And the way you activate velocity control is by setting position to infinity. And now we only need to set our velocities to whatever we want. And you can find, once again, you can find where this is on the Webots documentation page for motor. And if we look at this table right here, for position control, we need to set the desired position as well as specify the velocity it can go at. And for velocity control, we should set the position to infinity and specify the desired velocity. So once again, the Webots reference manual is a very useful guide on what you can do and what API calls you can make and what that achieves. So now back to Jeffrey. He's going to talk about the position sensors, aka the motor encoders.
Thank you, Victor. So I'm going to open the encoders.cpp file. This code is on our GitHub page, just like we said before, under day 1 and sample code. And this is just a demo of how you can work with encoders in Webots. And now I'm not going to go through every single comment, but they are very good, and you definitely should read them on your own time. But for the sake of time for this session, but we're not going to go through every single line. But basically, this is just a demo about how you can work with encoders in Webots. And it all revolves around this position sensor. So with all sensors and motors and robots, you have to have the appropriate include statement that I put right here, Webots position sensor.hpp. And then just like with the motors and the robot, we have to create a pointer to the position sensor object. And we can use this pointer called left encoders to count our encoders. And this is how you initialize it. Then we have to remember to enable it after we initialize it, and we pass a time step as our argument. And left encoders will return to us the number of radians that motor has traveled, or that motor has spun. So as you can see up here, we use the left motor pointer to initialize our position sensor. So now left encoders will always return the amount of radians that our left motor has spun. So using this, we can do a little math, and we can define the number of radians we can turn so our robot travels forward 1 meter. And again, the math is all in the comments, so you can read that on your own time. Then we can also figure out how many radians our motor has to turn for our robot to turn 1 degree. And that number is right here. So once again, if you're still a little confused, go ahead and read the comments after this video. So then, to actually use our position sensor, all we have to do is do our pointer, which is left encoders, arrow get value. And this returns the number of radians that our left motor has spun, right? And all this does is it checks if the amount of radians it has spun is greater than the amount of radians that it's trying to go. And this encoder target is defined all the way up here, and it's just radians per meter times 2. So now encoder target is the amount of radians our motors have to spin so that our robot goes forward 2 meters, right? And then this is just going to make our motors spin at velocity 5 until it reaches that target. And then it's going to stop both of our motors. So let's see both of these motors in action. So I'm going to go to encoders.cpp in our Webots text editor. I'm going to hit the gear and it should build. Okay, we can hit cancel on this. We're going to go to controller in our scene tree, double click, and then we're going to select, and then we're going to go to encoders because that's the controller that we want. We hit OK, and then now we're going to save our. Oops, so we're going to do that. Encoders. Okay, we're going to save our work. Okay, now we're going to run our code. Reset. As you can see, our robot goes forward 2 meters because that's what we did in our robot controller, right? So now, in the same code, we can also make it turn 90 degrees. If I comment this stuff out, and this basically defines how many radians my motor should turn so that my robot does a 90-degree turn, and then it goes ahead and it sets our robot to do a point turn. So then I'm just going to load this in again. So going to here and build one more time. Cancel. Okay, now if we hit play, our robot should do a 90-degree turn. As you can see, our robot froze right when it hit 90 degrees, right? So when this Q&A session is done, when this webinar is done, I highly recommend you go back through this code and read the comments because they're pretty good comments done by Victor. And yeah, they tell you the math behind all this encoder stuff. And that basically wraps what we're going to talk about for today. Now we're going to head over back to Victor, and we're going to talk about some challenges you can do, and you guys can also ask us any questions you might have afterwards. So, Victor?
All right, so once again, the two samples that you saw are available in our GitHub folder, as well as the world you just saw under day one. And these are the two samples, as well as the world which we used, which was called level one. So as of right now, we're gonna release these three worlds for you guys to do. And the idea is that they're progressively more challenging in what you're supposed to achieve. So in this world, we set up an automatic supervisor so that, let me, so that we have a world essentially that's going to ask you to follow these red markers. So currently the next red marker is at 1. And if we move our robot onto 1 manually, then we go to 2. And then once we hit 2, we go to 3, and so on. And then finally, when you're done, it's going to tell you that you're finished and you visited all the waypoints. So this is in order of these numbered blocks up here, just as a reference to tell you where your robot is supposed to go. So this is level 1. Pretty much all you need to do is go in a square pattern. We can also take a look at level 2. And you'll see this one's slightly harder. This time you just have to go in a zigzag pattern. And it's the same format as the last one, where it's going to ask you to follow these waypoints in order. And then finally, level 3 is significantly more different in that it's not so much a pattern that you have to follow, but you just have to go in order of the waypoints once again. 3, 4, 6. And we have a silver tile right here just to tell you where your robot originated. And you guys can also play around with the silver tile. And that is pretty much it. So for right now, we were thinking that since we have a bit of time, we can answer any questions you guys have, or you guys could start working on the levels 1, 2, and 3 worlds. And we'll actually have a system where you guys can submit samples of your robot and sample code doing the challenge. And depending on what we get, we can look it over. And if we want, we might release it during our next webinar as exemplar code. All right, so first thing is, are there any questions? You can send them to us in the chat.
Or if you actually want to ask questions, please feel free to raise your hand. Click the button to click raise your hand, then we can unmute you. Now, why don't we just go ahead since we have about 10 minutes, yeah, 10 more minutes. And why don't we let's just try to just do the first exercise together. So would you like just go ahead to go through it from the beginning to the end now? For anybody who here has already installed the Webot, let's just get it started so that we can actually walk you through if it's necessary to finish the first exercise even. That would be great. Now, my first question actually is that does anyone here have difficulty installing the software? Please raise your hand or put it in the chat. Jonathan was asking, is there a way to measure distance in between points in the world?
To measure distance in between points in the world, you can't click on a specific point and measure it, but when you do move an object, let me share screen. when you do move an object around within the world, for instance, if I wanted to get the distance from like this waypoint to that waypoint, if I move this, it actually brings up how many meters I'm moving within the simulation, and you'll notice that it's around 3 meters away. And same thing here, we can move it to the right, also 3 meters.
Okay, good. Winston, you said that you couldn't even start your Webots. Maybe can I unmute you so that you can describe what your problem is?
I can unmute myself.
Oh yeah, good.
When I open it, like it just gets like I run a Mac and I open it, when I like right click the icon on my desktop, it just gets stuck on force quit. Like it just says force quit and it, like in the tab, like the window doesn't even open up. I can't find it in command tab, nor can I see it in force quit. It's just like if I right click on the icon, it says force quit and that's it.
One question. Are you doing this from a laptop or a desktop?
This is a desktop.
Okay, so you have like any kind of like GPU?
I don't know. It's an iPad.
Oh,
That
it's
helps.
iPad.
It's an iMac. I'm not sure if that will help or.
No, it's an iPad. It's not really a desktop. It's an iPad. It's a Mac machine.
Yeah.
Perhaps then I would assume then you install the right packet, right? Because they have an installation just for Mac machine. And Python, did you install
Oh wait,
Python?
never mind. It works now. Wait, what?
Or magic.
Okay, I'm just gonna stop asking. All right, thanks.
Okay, let's see. There are quite a few questions here. Let's see. So Winston, that's good. Your Webot is coming up, right? So then I like to ask everybody start to writing the first code. If you have problem, I really like to see everybody at least get the first one, the simple one running, so that you have about a day tomorrow to play with it, so finish up the challenge. What we are planning to do is that we're going to send you a direction where you can upload your code, and as well as a video possibly. Then we will pick the best one and we'll give them recognition on our website. So just a little prize there. And then on the last day on 27th, we actually have a mini contest. So we're looking forward to that. But anyway, so let me answer another question. Zoom doesn't allow me to copy, so I'm going to just speak it. Let's see. When I load Webots, the FPS is really, really slow. But not only that, my whole computer is slowed down. Even typing a word takes, well, basically he doesn't have the right GPU to run it. Yeah, if you have a very slow machine, the GPU, well, that's unfortunate. I will not be able to help then. Yeah, it does have that because all this is about the graphic interface. But then if you can use your machine for like a computer game, then I'm surprised that you cannot do this though, unless your machine itself actually is pretty badly fragmented. So then probably my recommendation is this: if you actually can use a machine to play video game, then you should be able to do the Webot. Now, if you cannot write at this point, I would highly recommend and just make sure that you optimize your machine first, like do some kind of defragmentation and so on and so forth. So if not, then that's unfortunate. Next question. So we can use C. I thought we could use only Python. Victor?
Webots actually supports like a multitude of languages, including C, C++, Python, Java, and even like ROS. So you're not limited to just Python at all.
The thing is, when you get into the RoboCup Junior world, their user interface only allowed you to load in Python scripts. So we're still getting an official way to submit C programs or C++ programs for the world. We're still working on getting an official way, but to actually run C or C++ code in the RoboCup Junior world, you can just do what we did in this video. You can just go into the scene tree, load in the controllers, and then save your world, and it should still run like normal. You just can't use the user interface that's on the left-hand side. You'll see that tomorrow when we go over the actual RCJ world.
In short, that means that yes, you can. So you don't have to use Python. Right? Python is easier always because we all know what Python is about. But then this is really particular for C and C++. But just to answer your questions around, yes, you can use C and C++. Okay. Next question. I use it for computer game Unity. Or well, the fellow there who said that he couldn't run Webot. Like what I said, if you actually can run video game, you can run Webot. Now, may not be. If you have a very low GPU, yeah, you may run not very smoothly, but I'll be surprised that you couldn't even do it at all. So you need to stop the other video game, perhaps. You don't have any other like video games running at the same time. So I think that will help.
Yeah, Webot is pretty intensive, so I don't know, maybe give a reboot or something.
Yeah, the first thing, yeah, here's a good idea. The famous line is reboot your system. Yeah. Reboot it first, and then don't go start running it and running other games or whatnot which is graphic intensive. So just run the reboot your machine first, right? Now I like to know though, does everybody have a chance to run the reboot and do the first couple of lines exercises? No problem. Okay, now before I let you go, this is 45 minutes after 8. So before I let you go, I want to remind you that let me just go back to that share screen here. Make sure that you know where to find the source code and then a list of resources. Okay, that's very important. We are a big believer that we help you to be resourceful so that you can do a lot more work than even just what we talk about. Right? That makes life much more interesting. So now let's go back to that again. Now this is the link where you can get all the good info for the next few days. But however, if you forgot, you can always go to the site that everybody is familiar with, which is the RoboCup junior.org site. And this is where you're going to find the latest information about the RoboCup robot simulation league competition anyway. So go to that rescue, then the simulation demonstration, and it's this guy's right here, the rescue maze, the second one. Click on that. Now, if you want to go look at Python, this is what this tutorial is about. But if you're interested in doing C and C++, then you're on the side, just click on that. Click here, voila, then you come to the site where you're going to find all the resources. Okay, again, this is a really good card right here. It contains the whole list of resources you can find. This is very good, excellent documentation. Webots did excellent job in documenting their APIs. And then this is where you're going to post technical questions pertaining to Webots. But you are also welcome to go to post it on the RoboCup Junior forum, okay? But if you want to get quick response, let's say, then the team from Webots team, they encourage people to put that on the Discord. But otherwise, you are welcome to post it on the RoboCup Junior forum as well. We have put aside a special email address to ask questions, or we welcome opinions, what you like to see, what you like to cover in the next couple of days. And please feel free to email us about what your thought is. And last but not least is the link to back to the Python tutorials. Okay, and then next thing, mini challenge, the one that Victor was describing. You can download the challenge here. So then they describe the activities, but then once you go into that link, you will get all the information, the worlds you need to download, and some of the sample codes as well. So that will be really cool. I cannot emphasize enough. Do look up the documentation from Webots. You will find out a lot of good information. And also in the future, we will continue to put more sample codes and then technical explanations about triangulation and all the math work and all. Okay. So again, thank you for coming. And so I will hopefully see you guys tomorrow, and have a good night, guys. Unless you have questions, then please feel free and raise a hand and unmute yourself, and we can answer questions. Otherwise, then have a good night.
Will this be a competition in the fall?
We are looking to do that, yes. But then the details will really depend on the outcome of this workshop,
Oh, okay.
right? We like to get a sense of how many people is actually interested doing it, and then the background, and then how much they can do, and so because as always, Roboco Junior is more geared towards the AI side, so they like to really stretch as much as they can as far as the learning perspective. So then we need to gauge how much that all these participants is going to be able to do. So that's why we, at the end, we do have a mini contest. So that will be a good chance for us to test it out, how much everybody can do by September. So the target is, we hopefully is at the end of September, we have a we'll have actually a bigger scale competitions worldwide. Does that answer your question?
Yeah, it does. Thank you.
Okay, very welcome. Any other questions? No? Okay, well, have a good night, guys. Mark, could you stick around, Mark? Mark, this director, Mark Yan, I just saw your name. So Mark, do you stick around? I need to ask you a question. So have a good night, guys. So I hope to see you tomorrow then. Mark, can you unmute yourself?
Oh yeah, hello.
Hello, Mark. Hey, your teammate has been trying to contact you, by the way.
Oh, uh, Joseph?
Yep.
Yeah, I sent him the consent form.
Oh, okay. Very good.
Yeah, I already sent him the consent form.
Okay.
I think we just need Ryan.
Oh, okay. Oh, it's Ryan. Oh, maybe I get the name confused then. Okay. I thought that was Ryan. I saw his name here. Okay, very good. So hopefully see you guys tomorrow then. Try out the exercise. That would be wonderful.
Yeah, Miss Elizabeth,
Yes.
my internet cut out halfway into the meeting, so I think I missed some stuff. How do you actually control the robot? Do you which files do you modify for that?
Victor, Jeffrey.
Isn't this going on YouTube?
Oh, it's
Miss
on
Elizabeth?
YouTube?
I think, right, Miss Elizabeth?
I'm sorry. Oh, I thought he was asking about how to control. Oh, I'm so sorry, Winston. Are you asking about how to upload your code?
Oh no,
No,
how
no.
to control the robot. That's what I'm asking because
Are we posting this meeting on YouTube?
Oh, yes, we are. Yes.
Yeah.
Right.
Okay.
Right. But then,
Joe, do you want-
well, yeah, go ahead.
Do you want us to answer it like kind of briefly right now, or do you want to watch the YouTube like tomorrow?
no, which files do you modify, or where do I type in my code?
Oh, okay. I can just briefly go over that again. Yeah,
Yeah,
sure.
why don't you do that? Yes.
Um,
That's not sharing.
Okay, so when you probably first open Webots, there's gonna be nothing here, no text editor. So you can first open that by going to Tools and then Text Editor. And Webots has a wizard to create new robot controllers. So I recommend you use that. You just go to Wizard, New Robot Controller, Next. You select C++ if you're gonna be using C++. And then you name your controller something, like my controller. And it's going to automatically create the CPP file for you. And this is just a template CPP file. And this is where you're going to type all your code into. Now, the thing is, after you write your code, make sure that you build it in order to compile your program. And that's going to compile your controller. Now, the last thing you have to do is make sure that if you click on this robot, right, these robots have controller programs attached to them. And right now, it's not set to the controller we just made. So we can select a different controller by hitting select and selecting my controller or whatever controller you want and hitting OK. So now, whatever compiled code that you have written over here is going to get executed on the robot once you run the simulation. Is that it?
Yeah, that makes sense. I'm trying it right now. Thanks.
Can you just, well, how long would that take? I mean, just to get it started. I mean, it's a couple minutes. Can you do that now? Are you doing it now?
Yeah, I have it open right now. It seems to be
Okay.
working fairly quickly. I can just, it's the controller. I just need to change first. I think I need to restart the world or something. Which one? So I need to change the controller to my controller. And if I run this, it should spam me with printf, I think. Oh, I changed the wrong thing. Whoops. Yeah, so I just need to change the controller to my program, right?
Yeah.
Okay.
Sounds good. All right.
All
Okay.
right. I should
All
really
right.
get this too.
You're welcome, guys. Have a good night, guys.
All right.
Good night.
Thank you.
You're welcome. Anyone had any questions? Andrew's still here. Do you have questions, Andrew?
Yeah. I need to update. Whenever I try to launch Webots, it crashes, and I'm trying to update my graphics driver.
Oh, okay. Well, unfortunately, do you have guys have any suggestion?
Yeah, updating your graphics driver is a good way to start. We actually had somebody from like an earlier session with the same problem. Webots has a list of supported graphics cards and graphics drivers. That's also linked in their documentation page. I'm not sure if you're going to find that helpful, but I can just send the link in the chat.
Oh, that's actually a good idea. Maybe I should make a special link on the website. So I like to collect the special problems that the typical problems that people will encounter. Then I have a collective, like a little knowledge base for them to look it up. So, so it would be good if you can email me, Victor and Jeffrey, that all the questions you have collected in the past. I will try to create a knowledge base for that. So I will put a bookmark on that driver installation then. Okay. All right, Andrew, so good luck. Yeah, okay.
I didn't know which driver to download.
I'm sorry, say it
I
again.
didn't know which driver to download. Thank you.
Oh, now you see, oh, let me see. Oh, Victor, you send it to me only.
Oh, sorry.
That's
I
okay.
must have
I'm
done
gonna
it in
put it
private
on the,
chat.
yeah, go ahead. Would you put that? Because I can't copy and paste. Andrew, Victor is gonna put it on, yeah, there you go. Do you see the link?
Yes. Thank
Okay.
you.
All right, and there's also a list of system requirements they have. Yeah, so see if you can follow the instructions and if that's helpful to you.
Okay. Thank you.
Oh, you're welcome. Don't forget, if you have questions, just post it online, and then we'll try our best to cover all the questions you may have.
Yeah, if you have further problems, you can post it in like the Discord.
Yeah, yeah. You like what they said. I mean, if you want a fast response, Discord is the one to go because Victor and Jeffrey will be there, and some other team will be there too. All right, very good. Have a good night, Andrew.
Thank you. You too.
You're welcome. Yeah.